Okay, we're moving on to 7.2. 7.2 is multiplying with the same base. So, first of all, one of the things I should talk about is if I have x raised to the n, the x technically is considered the base. It's the base to the exponent. So today we're talking about numbers that are the same base that we're multiplying together. This n is, of course, our exponent, sometimes called our power. All right, so that's what we're going to be working with today. The rule I want to talk about is if I have two of the same base multiplied together, what do we do? So if I have x to the n times by x to the m, the rule says I keep the base and add my exponents. So keep the base and add exponents. All right, so for example, if I had x to the third times by x to the fourth, I would have x to the 3 plus 4, or x to the 7th. The reason this works is x to the third is really x times x times x. X to the fourth is really x times x times x times x. And we're multiplying them all together. How many x's are there? There are 7, right? So this is our rule today we're working with. So in the first section, we're going to start off with an example of the first section. In the first section, example number 1, I simply want you to keep the base and add the exponents. So I don't want you to simplify or evaluate it any further than that. All right, so for 8 through 12, rewrite with one base. So let's say I have a to the 4th times a to the 9th. I keep my base, which is a, and what do I do with my exponents? Add them. So 4 plus 9 is 13. Same as if I had a number there. Let's say I have 3 to the 2nd times by 3 to the 7th. I keep my base, and I add my exponent, just that.
So what happens if we have two different exponents and two different differences?
We're going to get there. Patience. Patience. All right, so we have the same base there. We keep the base, and we add our exponents, so we get 3 to the 9th. In this section, I want you to leave it as 3 to the 9th, just on these first few problems. Okay, so don't evaluate it. Let's do one more right here. What if I had negative 2 to the 4th times negative 2 to the 10th? How about 10th? We get our base is technically that whole group of negative 2. That's our base. And then we add our exponents together for a total of 14. First section seems pretty easy, right? Okay. Example 2. In the next section, this is 14 through 18. I'm going to ask you to simplify, which means you're going to simplify as far as you can, all right? So, for example, let's say I have, we'll start off easy. Let's say I have w to the 3rd times w to the 2nd. What do I get? W to the 5th. I keep the base, I add my exponents. What if I had h to the negative 2 times h to the negative 4? I keep my base, which is h, and add my exponents. Correct. Thank you, Joel. We got to put it down in the basement because it's got a negative exponent. He's not happy where he is, so we're going to move it to the bottom. You get 1 over h to the positive 6. Okay. What if I had negative 3 to the 4th times negative 3 to the negative 2 times negative 3 to the negative 2? My base is negative 3. I add my exponents together. What do I get? So my whole answer is 1. All right. Now, what have you noticed I don't have on any of these problems yet? Different numbers, coefficients, right? So let's start there. So when we have a coefficient, say I have 3x squared times by 4x to the 9th. When you have a coefficient, 1, you multiply the coefficients. 2, you keep the base. And 3, add exponents. So we really haven't done anything else except multiply the coefficients. So on this one, we start by multiplying our coefficients. 3 times 4 is 12. Our base is x. And then we add our exponents. 2 plus 9 is 11. Not too bad. So can I make it a little tougher? I can up it a little bit. Make it a little tougher. Let's say I have 5 a to the 3rd b to the 7th times by 6 a to the negative 2 b. All right, so first we start by multiplying our coefficients together. What is 5 times 6? 30. All right, we're going to put our base of a. So I have up here, I have a to the 3rd, and I have a to the negative 2. I keep my base and add my exponents. I get a to the what? 1. All right, then my next base I have, which is different, is b. So here I have b to the 7th, and I have b to the what? 1. Magical 1's always hanging out, right? So in this case, I'm going to have b to the what? 8. Very good. So even though I added another variable, we keep the base and add those exponents. All right, so one last one in this section, and we'll move on. How about this one? Let's say I have, 4x to the 3rd times negative 2, y to the 4th, times by 3x to the negative 6. All right, step 1, we multiply our coefficients. What do we get? 4 times negative 2 is negative 8, times 3, negative 24. Now we're going to start with our x's. I have x to the 3rd, and I have x to the negative 6. Good. X to the negative 3. Then I have a y. Y to the what? 4. Am I done? No. What do we have to do, you guys? Correct. So I have negative 24. Y to the 4th. My x to the negative 3 has to go to the basement. And my exponent becomes positive. All right, any questions on that section? Okay, now I'm going to skip over question 30 for a few minutes. We'll come back to it in a little bit, because you can probably guess what it is. We'll be back. Okay, example number 3. Example 3. Example 3 is going to cover 22 through 26. And it says to simplify, what I want you to do is use calculator. Yep, and so I want you to practice putting this in the calculator. Are you ready? How about 4 to the 3 halves. So you type in 4, use your little caret button, and in your exponent put 3 divided by 2. It is 8. I agree. All right, how about, let's do 64 to the 1/3.
4.
Very good. How about 100 to the 1/2?
10.
All right, so everybody understands how to type these in your calculator. There's only 3 of them, but that's all you're doing, okay? Understanding that you can evaluate even a fractional exponent. Yes. All right, moving on to example number 4. Example 4. This is for 28 through 30. 28 through 30. Again, I want you to simplify the expression. We're going to follow the exact same rules that we did before. So let's say we have 2a to the 1/2 times by 3b to the 1/4. We're going to times that by -2 a to the 3 halves times by 5b to the 1/4. All right, same rule from before. We multiply our coefficients, right? So we're going to multiply 2 times 3 times -2 times 5. 2 times 3 is 6 times -2 is -12 times 5 is -60. Now we're going to start with our a. We have a to the 1/2 and we have a to the 3 halves. So we add our exponents. 1/2 plus 3 halves is? 2. It is 2. It is 4 over 2, which is 2. Right? 4 over 2. Now we go to our next base, which is a b. b, we have 1/4 plus 1/4, which is 2 over 4 or 1/2. That is the answer you can keep. That's it. All right? So just because they're fractional exponents doesn't change anything. You still add them together. Okay? All right. Example number 5. And we got to do a little bit more learning on something, and then we'll almost done. Example 5. This is going to cover your 32 through 36. And it says, complete the expression. So maybe it looks like this. You have 5 to the 3rd times by 5 to a little gray box in your book equals 5 to the 9th. What do you think should go in that beautiful little box there? Probably a 6. That's right. Okay, how about this one? Sorry, just what we're doing. Let's say I have x to the little gray box times by x to the -2 equals x to the -5. That? Good. -3, I agree. So we need to make it a little tougher, huh? Okay. How about one like this? Let's say I have x to the 3rd, y to the gray box, times by x to the gray box equals y to the 9th. So now I got 2 boxes. Nope, the boxes can be different because they're on different bases. X to the what? -3. Why is it -3? Yes. Very good. X to the 3rd and x to the -3, they end up crossing out, right? It's x to the 0 and it becomes 1. What is the box on y? 9. Perfect. All right. Super easy. Okay, so here's what I need to talk about last, which will take us back to our one-word problem. Okay, I need to talk about scientific notation. All right, scientific notation is always written in the form where you have a coefficient. So I'm going to say let's go with A times 10 to an exponent. The special thing about A is that it has to be between 1 and 10, right? If it's not, we have to do some things to it. We got to move our decimal and stuff. Huh? We're getting there, but not quite to that extent. Just a minute. All right, so here's what I really want to talk about today. Is when I am multiplying scientific notation together. So let's say I have 3 times 10 to the 4th, and I'm going to multiply that by 2 times 10 to the 7th. This follows the exact same thing we were doing before. We multiply our coefficients. So we're going to multiply our coefficients in front, which is 3 times 2, which is 6. We add our base, or write our base down. We keep the base, which is 10. And then we do what to our exponents? We add them. So 4 plus 7 is 11. Right? Now, before you keep going, though, you have to check and make sure this leading coefficient falls between what two numbers? 1 and 10, right? If it's below 1, it's too small, and if it's above 10, it's too big. So then we'll have to move our decimal place. All right? So one more really quick and talk about that. So let's say I have 2 times 10 to the 5th times by 6 times 10 to the 2nd. Multiply our coefficients. We get 12. You keep your base, which is 10, and we add our exponent, which is 7. This time our number is too big, right? So that means I have to move my decimal over 1. But then what are we going to do with our exponent? So if we move it... Okay, so here's my rule of thumb for you guys to think about. If we're moving it, if the number, let's say it this way, if the number is too big, add to the exponent, and if the number is too small, subtract. Okay? That's the math way of doing it. So in this case, we have to move it over once because it's too big. We're going to add 1 to my exponent. So this becomes 1.2 times 10 to the 8th. Okay? So now, what does that have to do with the one problem we skipped over? So glad y'all asked. Last example. What example am I on? Thank you. Example 6 has to do with number 20. So in number 20, you have a word problem, of course, and they're asking you to multiply several things together. Okay? That's all you have to do. So maybe they tell you that, maybe, I'm making up the numbers here. Huh? Let's say the human body contains 2.7 times 10. What exponent do we want? 42. I heard 7, okay. Microliters of blood. In each, there is about 8 times 10 to the 4th white blood cells. My question for you is, oh wait, this is microliters of blood per pound. This is per pound. My bad. I left off that. Per pound. Per pound. All right. In each, there is 8 times 10 to the 4th white blood cells. How many white blood cells in a 120 pound, 120, come on, pound adult? All right, so all this is asking us to do is to multiply these 3 numbers together. We're going to multiply 2.7 times 10 to the 7th. We're going to multiply it times 8 times 10 to the 4th. I wrote my 7 in the wrong spot. Let me fix that. And then we're multiplying it by 120. All right, so the first thing we're going to do is you're going to grab your calculator for me and multiply 120 times 2.7 times 8. 242? 332. All right, then we keep our base, which is 10. And what do we do to our exponents? We add them. So 7 plus 4 is 11. Now look at that coefficient we have in front. Is that too big or too small? Way too big. So we have to move our decimal place 2 places. So we're going to add 2 to our exponent. So I have 3.32. Oh my goodness. Times 10 to the 13th. Exactly. Okay? All right, that's it. Any questions? All right, it is only 10:42, so you still have 8 minutes to work. So please feel free to get started in case you have some questions.